to visit KTH Sweden. So I may come back again since it's so close. We ready?
Whenever you're ready. I think we might still want to wait for a few minutes, but
sure. Yeah.
As I think you were pre-warned, this is the toughest time of the year.
Not a problem. Yes.
To attract
I understand
crowds.
that. Yeah. I understand that. Yeah. And because you've been waiting for this summer for a long time, and it's a well-deserved break that you must have. And a lot of people go on holidays and travel around. When I first came on Saturday, the road is very empty. Mm-hmm. So the trip from airport to the hotel is very smooth.
Yes.
They say in the newspapers that for tourists it's the worst time to visit the Helsinki during this midsummer weekend because there is no people in Helsinki.
Nowhere to serve the tourists.
Yeah,
I mean, everything is closed.
Yeah.
On top of that, the city is empty, but you can't access any restaurant.
Well, it's only Saturday, is it? Only Saturday and Friday, is it?
Well, it's mainly Friday and Saturday are the worst days. But then, actually, many people start their holiday season from the midsummers onwards. So then everything calms down, and basically it's very hard to make business because you can't get hold of people anymore. Yeah. It's really July is the summer month, the holiday month.
I was talking to people from Elisa, this telecommunication company, and I said I'm coming, in June, July, and they said no, don't come in June, July. We're not going to be around.
Exactly. Well,
that's all right.
If you're ready to start,
I'm ready. I'll just get some more water. Take place, I think.
Let's wait for a second.
Okay, shall we start?
Yeah.
So, welcome everyone. Thank you for being here for this summer edition of EIT Digital Lunch Talks. My name is Kai Huotari, and we have a very special visitor all the way from New Zealand here today, Professor Xun Xu. So he has, he's professor at the Department of Mechanical Engineering at the University of Auckland, where he also leads the Center of Innovative Manufacturing and Materials program, right?
Yeah. And
you have published extensively in the areas of cyber-physical systems and CAP and CAD and CAM and additive manufacturing. And today he's here to talk about cloud manufacturing, industrial, Internet 4.0, and intelligent manufacturing. Which is very topical for us. I don't know if you already discussed with Tatu, but cyber-physical systems is one of our focus areas in ICT labs. Cloud computing is another one. We are building an industrial Internet 4.0 center here on the Aalto campus. So this is extremely relevant for us, and we're very happy to have you here. Just want to mention, for those, I think we have listeners or watchers online, so people who are watching this on the stream. So if you have questions, please use EIT, hashtag EIT Helsinki if you have questions for Professor Xun Xu, and then I will read them aloud for you in the end of your presentation. Thank you.
That's good. Thank you. Well, first of all, thank you for
We need to use the mic.
coming.
No.
You think it's all right? Yeah. I haven't got a particularly loud voice, though.
It's fine.
Yeah, now it's in the middle of the summer here, and the summer is very special in Finland compared to other places. So I understand that there's a scarcity of people attending seminars and all that. Well, you can see the title here. I've changed a little bit. Basically, I try to combine two talks that I used to give into one. So it's going to be fairly sort of abbreviated. And the reason I combine them is that I think they actually related to each other, and there's a very close connections between the two topics. Well, the first topic actually has got three elements there, but they are, of course, connected as well. Well, I guess some of you asked me why I'm here, why me, why this time. This is actually an initiative between New Zealand government and European Commission. We actually had a joint proposal and funded by European Commission and New Zealand governments to try to encourage collaborations between New Zealand researchers and researchers in Europe. So it's the title of the project is Factories of the Future. So we had a group of visitors from Europe in New Zealand early this year. It's one person from VTT, I think. And then this is return visit. So I'm part of the 5-man delegation from New Zealand, and others. We went to Germany first, and we visited IPA in Stuttgart, the University of Stuttgart, Dresden University of Technology, and Chemnitz as well, and Cologne. We visit FIT, another Fraunhofer Institute, and then the team disbanded, and most of them have gone back, and some of my colleagues already arrived back in New Zealand. So I'm still here because I think there's a sort of quite a good synergy between what we doing in New Zealand, but also what you people are doing here in Finland. So that's the reason I'm here. This is my last talk and last stop, and then I will be on my way home this evening. Well, this is actually showing just the research organizations in the country, the universities and the research institutes in New Zealand. You can see New Zealand has got 2 islands. I'm from Auckland, so University of Auckland, one of the 8 universities in the country. And then we have some other universities, and delegation only have 5 people, so they represent, we try to represent the entire country, the research organizations, all that. And the capital is Wellington in middle, and I remember when I was here last time, people were saying New Zealand is perhaps the furthest country away from Finland. You can almost stick a hole into the earth and you come out at the other ends, and that is New Zealand. So to some extent, we far away from each other, but I think there's a lot of similarities between these 2 countries. Our governments compared to Finland in many different aspects, you know, economy and research activities. And in many cases, I think we try to sort of learn some of the technologies that you have developed and the way you manage your R&D and other aspects of economy. So I just probably should move on. So as I said, the 2 topics then is one is related to cyber-physical systems and industries 4.0 and smart factory, and the other is cloud manufacturing. So I sort of have half and half. Just the first topic, first set of topics. I'll just talk about the CPS briefly. It's probably not new to many of you at all. And Industry 4.0, smart factory concept, industrial internet, which is sort of American sort of way of thinking about Industry 4.0. So to start off, maybe some preamble, sort of background information about why we're coming to a time that we need to think about these different topics and we need to spend time and effort on this. Well, the first thing is globalization and decentralization. These days, you don't make things in one place. You actually have people helping you out from different parts of the world. And the production systems are decentralized in many ways. And also we have a data explosion in a way that you can get data easily from almost anywhere. And so it's a good thing that you have data, but it's not so good if you don't know how to deal with it and how do you manage and how to analyze it. So that's why data in many cases doesn't equate to information. So you really have to analyze it and process the data so that it becomes useful information. So that means the data analytics is also important in this sense. And this connectedness and industry of things is also coming our way. I think it's been talked about in different contexts. The way that the things are connected, but also the people and the systems are connected. And these are also important. And then if you look at the production system, I think we used to talk about value chain, when it comes to production systems. I think now we're looking at not just a chain system, but it's actually a network. It's a value network. Things are connected in a more complex fashion, not sort of in a linear fashion. This happens first, and then you go to next phase. So network is a key word here, I think. We just have to perhaps refocus a little bit. Now, cyber-physical system, I have to be brief on this, and there's probably a lot of expert here. But what is it? Well, this is perhaps my understanding, if you like. It's about sort of combining the virtual world with the physical world. Obviously, that's how the terminology came about. It has a focus on connectedness and also with intelligence. So it's no good just connect things together. You hope it works, but you really have to introduce intelligence and in the whole system. Well, when you communicate between different systems, between different machines, here, M2M communication, we have got that in the past. You may say it's not new. Well, it is true and it's not true. But what is new here is we're actually talking about semantic communication. So we're talking about things can communicate in a meaningful way, and people, and systems can understand semantics, not just syntax. So I think that's the key thing there we're looking at. Well, people are saying, well, cyber-physical system, is it not just embedded system? Well, I think it is technical term, it is embedded system. But people try to focus on closed embedded systems, or embedded systems can be connected with other embedded systems. So it's perhaps a ecosystem for all the embedded systems, that they work cohesively and in a coordinated manner. And this will provide, a lot of functionalities once you have connected things together. When it comes to manufacturing, and people try to sort of have a manufacturing version of CPS, and this will be CPPS, Cyber Physical Production System. So this is perhaps more of our focus. But don't forget, cyber physical system can be anywhere, can in social worlds, can in any other walk of life. Then this Industry 4.0 came about. It's originated from Germany. That's why I keep the German spelling of industry there. I guess it's fitting there because it does come from Germany. Although when we were in Germany, all the presentations given by our German colleagues, they use proper English spelling there. Well, I think there's perhaps people talking more about factory level Industry 4.0 concept. What I think the way to understand this is that there are two aspects there. The one is really looking at the consumer, the customers, the users, and the other is looking at the factories that are making products. So really Industry 4.0 is about cyber-physical systems combined with perhaps Internet of Services, then give you smart products. So it is the product that becomes more intelligence, become smart. That's used by the customer. So that's on the product end, what you're making. And then on the other side, the factories that are making these components, these systems, these products, they want to be smart as well. And then the way to do that is to actually combine with the smart production processes. Then you have smart factories. So I think this is more talked about rather than these aspects. The smart factories can be very smart, but if you don't make smart products, it's no use. It's useless. So I think these two things come together. So I just got a few examples of this and a couple of examples of the other, the smart factories as well. So these are the two different contexts, don't forget. When we were in Stuttgart, we visited Daimler in Stuttgart, visit their factory, and this we had a talk given by Daimler talking about their vision. This is their concept car. They call it FO15. It was first introduced earlier this year in Las Vegas. They call it luxury in motion. This is a typical example of smart products that company are making. Well, the few key aspects that are very interesting. One is really emphasize the interaction between passengers and the car itself. So this is in-car communication. So this is again bringing closer the passengers and the car they are in. And the other is interaction between the vehicle and the environment that's around the vehicle. So they had this extended sensor system. They try to get data from outside the car, around the car, and then to do some sort of processing and analysis. And they're also looking at connections between other vehicles. So vehicles talking to vehicles on the road. So that's another scenario, I think, if you like. So I think these are all indication of product and system being made to actually itself as a cyber-physical system, but it's also related to the concept of Industry 4.0. Just another slide about this car here. Some examples of interaction between vehicles and environments. For example, the car can interact with the pedestrian. They can have this whole array and matrix of LED displays and just to communicate with the pedestrian. And here they can project a zebra lines there so that pedestrian can travel, can cross the roads and safely, and can be seen by other people, other car users, other cars, other drivers. So this is really trying to communicate with the pedestrian outside the vehicle. And this is communication with the traffic behind the car, which can display different signs. Here, I don't know whether you can see this. This says slow, and this says stop. So it's not just an indicator, but it can. I don't know whether it can speak. But in this case, it's just to display some messages. Again, I would say it's just indication of how systems are being produced to be able to communicate with people and with other systems. So I think they all come under the same umbrella of cyber-physical system as Industry 4.0. Well, there's a lot of articles around this concept car. You can go online and have a look. So I think I won't go on talk about this aspect of smart products. I'll just focus on the other side, which is production systems and how we can actually use the technology to really build a smart factory based on CPS and other similar technologies. Well, there's no need to sort of go into details of this diagram. As anybody knows Industry 4.0 will understand this diagram. Well, what it says is really, this is coming out of Germany, of course, really looking at how industry has evolved through different stages, driven by different technologies at different time. And so this is driven by water and steam powered system. This is second stage revolution is driven by electrically powered systems, and then we have this IT-driven industry, and then this is industrial revolution based on CPS. I think this is IT-assisted periods, and this will be IT-driven or IT-centered industrial revolution. Well, you can debate about whether it's a 4 revolutions, or 3 revolutions, or even 5. Well, I think that's probably not the key thing here. But if you think about the progression, the 4 phases there, as we've seen, and then when you look at our society now, you can probably understand why we are at this stage, at this point in time, that we need to think about cyber-physical systems. Well, really, digitalization of economic and social processes happened quite a few years ago. You know, this is what I consider first wave. It started since the 1980s. I mean, things like banking systems and consultings and publishings, you know, you can do things online for banking and for a long time. You don't have to go to the library to get a paper to read. You can just go online as a digital version. So I think this has happened already, but this is, remember, is really on the social process and economic side of this. And what we are seeing now is perhaps a second wave, which is really looking at physical systems being made addressable over the internet. So it is a natural progression, the way I see this. And it is the time that we actually look at the physical systems and how we can make it cyber ready and internet addressable, and so they can communicate with each other. So if you look at the whole landscape of digitalization of different things, it is the time that we are looking at these issues. Well, smart factory is actually what we really need in the end. It doesn't matter what terminology, what technology you're using, cyber physical systems, Industry 4.0. It doesn't really matter. What I need is a smart factory which can actually do things autonomously, for example, and it's perhaps not just the ICT-based control, but also the components, machines, and service robots, and these different elements of a production system can also communicate meaningfully and can act accordingly and autonomously. So it's actually another level further over this ICT-based control. And because you can sort of, it can have this autonomous acting sort of feature there, it will be easy to optimize the system for individualized products. So this is where we're going. And it's also easy to actually reconfigure your system, and also easy to communicate with other resources outside your factory. You know, you might need to have some resources from a different country, and so this is why cloud manufacturing comes in here, really trying to bring resources on a global scale. And if you do this, you have very efficient resource utilization. And sustainable is another key word here, and service-oriented practice. That's also important, because I think increasingly this is another sort of key words I want to emphasize. We're increasingly moving into service-oriented system and products. And so I'll talk about this in a minute. Again, this is borrowed from a document from Germany. It just illustrates the smart factory concept. I mean, as I talk about this, it's about smart machines which can communicate in an intelligent way. And then they form what we call cyber-physical production systems. And then factories, they are also interconnected. That's actually quite important. And so making sure this is not sort of isolated and self-enclosed system or factory. And these different smart factories can actually operate over a cloud network, and so that resources can be shared and virtual enterprises can be formed. So that's, I think this is a good diagram to sort of segue from cyber-physical system to the cloud-based technology, if you like. Now, I mentioned about the American way of interpreting all of this, and very often they have a different focus and different view of what we are talking about. Well, they're not using the words cyber-physical system that much. They're not using the words Industry 4.0 that much in the US. But it's actually driven by some major businesses and major companies in the US. In this case, it's GE. They actually started looking at this issue quite a long time ago. So the term they're using is industrial internet. Well, in my view, it's same thing, you know, Internet of Things, Internet of Industrial Things, cyber-physical systems. They have three focuses there when it comes to industrial internet. Is this machine that's being made intelligent. Well, that's not new. It's the same as the machines in the Industry 4.0. Advanced analytics, this is about processing data. That's not new either. People at work, and they really emphasize this aspect. I think it's important that I think it's quite fitting here that to really not to forget about the workers on the shop floor, the people who are using the system. So the three aspects they're looking at this. But in essence, I think it's the same concept as Industry 4.0. So we're not debating which one is correct. They don't have 4 industrial revolutions as the Germans have. They have 3 waves. Well, again, I won't go into the detail of this. It doesn't matter. It does not matter. What matters is at this stage where we are in now, how do we react? What do we need to work on? Okay, so they call it industrial internet. So machine-based analytics, physics-based and deep domain expertise and automated predictives and all these terminologies. I think it's basically Industry 4.0. Well, what's actually more interesting for me, this GE concept, is really this prediction from GE. They actually work with World Bank. This is very early on in 2011, looking at the potential GDP increase with implementation of industrial internet. So if you look at the global GDP, there's 70 trillion, around 17 trillion, and it's split into between developing economies and advanced economies. Then for each one of these, there is a non-industry economy sort of contribution, and then it's industry economy. So industry economy, non-industry economy. So we're interested in this industry economy, of course. That's where we are working in there, and that also has the quite a big share of this entire GDP map. But if you look at the industry economies, there's 2 sort of parts there. One is manufacturing contribution, and the other is others, the rest. And here, manufacturing and the rest. I can see manufacturing actually form the bulk of the GDP contribution. So I think that's very interesting in terms of the experts are predicting about the impact of the technology in manufacturing area. I think it can only be underestimated in my view. So that somehow tells me it is the area we need to focus on. The manufacturing is this area we need to focus on. So these are two big numbers there if you compare to the non-industry contributions there. I just want to sort of come back to highlight some of the key words. One of them is industrial things. This is really about connecting things together. And this data and data analytics and intelligence come out of your analysis of the data, and autonomy is also important. I talk about service. I'll come back to this in a minute. Very important concept. Very important concept. I think businesses realize this sometimes unknowingly. Smart products is the only way that we can sell well of whatever you're producing. The car we talk about, the Mercedes-Benz, the concept car, of course, is a good example. Smart factories, talking about autonomics of production, which means it's a very high level sort of intelligence introduced. Well, this is perhaps sort of the first lot of topics in cyber physical system, Industry 4.0, and smart factories. Now let's just move into the second lot, and these are connected, and cloud manufacturing or cloud-based manufacturing, whatever you call them. And I think it's actually, we're talking about new way to run business, new way to run manufacturing business. As I said, I combined these two talks together, so I've overlooked I was just past the first two sections there, and I talk about service science. Remember, I talk about service. It's a very important concept in my view. And then I talk about cloud manufacturing and how do we define that. I'll give you a couple of examples there, and then talk about some other aspect of cloud manufacturing. And then I'll finish off. So this is, if you like, the second lot of the discussion. Well, cloud computing comes out first, of course. So when you talk about cloud manufacturing, the first thing you think about is cloud computing. The key thing in cloud computing concept is cloud computing services, basically offering things as a service. You pay as you go. I mean, it's a very important concept. It's probably one of the key concepts why it survives for so long. I think it will continue to survive. So you can offer infrastructure as a service and platform and software as a service. And so that's cloud computing service, why they sort of can't be separated. And service science, you can see I have a word science behind service, and believe it or not, service is being considered as a science. This has actually come out of UC Berkeley working with people from IBM. So this is, I think, about 5 or 6 years ago. They view service science as service science management and engineering, so SSME. They have this interesting logo there as well. So this is a science, it's a management science, is engineering as well. So I think they start to offer degree programs on this as well. Well, when you talk about service, we know service in the traditional context, but we can actually trace back to this book published by Professor Daniel Bell, really looking at the industry revolution. This is in 1970s, a long time ago. He's talking about what we are going to sort of experience in terms of the revolution of manufacturing industry. So he's talking about knowledge-based services will overtake manufacturing. Okay, well, it has happened to some extent. And the services in general will swamp manufacturing as a source of employment. Now, the key word is service, but I'm unclear about whether Bell thinks the service here that he's talking about is actually another version of manufacturing business, another version of making products, or it is more sort of traditional kind of service concept. But in any case, service is coming our way, and we cannot ignore that it is becoming a normality here for not just people like us, but also for businesses, for manufacturing businesses. I mean, if you talk about service, there's a different concept that this is the service-oriented architecture borrowed from IT industry, of course. So you have service provided and service requester, and the important thing here is the service register, of course. If you want to coordinate services in a proper way, then provide better service to the requester. This is important. And car manufacturing, to a certain extent, utilizes the similar concept. So I think it is quite clear that manufacturing businesses are being transformed from production and physical system-oriented business into service-oriented business. So I think businesses are no longer just producing a physical product and then sell to customer, then they forget about it. It is not happening that way anymore. They're selling a solution to the customer. And that solution has got the actual product, but also service elements perhaps, solution elements in there. So it's a complete package. And the manufacturer will try to still keep the connection with the user that are using their system. Well, there are many, many examples there. In my university, we have staff common room like your common room here. Our coffee machine, we do not own the coffee machine. We didn't buy a coffee machine. We buy the service. So we say, look, we want to, have a coffee serving site, and we have so many people there wanting, using the service, and so we basically they come and put a coffee maker there. They come and top up coffee beans. If there's a problem, they come and fix it. If there's a new version of the coffee machine, they will come and replace it. We are buying a solution, a service. We are not buying that physical machine. So it is changing, and many, many examples there. So this is important, service-oriented kind of concept. So if you look at this is sort of very conceptual level of understanding about a product. If you're making a product, if you look at which part of the products that's giving revenue to you. So the revenue resource is 100%. You're selling the product or service for that much of cost. And the product itself may have some hardware components. For example, if it's a car, of course, the car itself is hardware-based systems and products. And then you have software-based kind of elements in there. There's intangible services and analysis and monitoring capabilities there. And so I think the trend here is in early days, you can actually sell a product at a good price with very little software components there. I mean, as long as you make a brilliant machine tools, and and people can use them to produce components easily and give a good accuracy, that's fine. But increasingly, this software components is actually overtaking the hardware parts there. I think that's the trend we are seeing. So really, you have to think about this part here. Whatever you produce, even if it's a car, you have to think about this. I mean, in this case, in this days, cars have got a lot of electronics and embedded intelligence in the cars. And the good thing for advanced economy to think about this is also because hardware-based things can be easily copied. You can just strip it down and measure that, and then you can reproduce the system. But if it's a software, unless you have unique skills, it's difficult to copy. It can easily sort of protect your IP in there. So there's a lot of examples of cars, smartphones, and you think about it. And the key thing, of course, is total integration of these two things. They have to come together. So again, that's the thing that we're looking at, and the software-based sort of components really contributing to the service part rather than the actual thing you're buying. I just want to give you this example. This is the electric car coming out of the US, Tesla. You probably heard of this. Very typical sort of popular electric car in the States. What they call this is app on 4 wheels. And so this is a good example. Sorry? Tesla. Oh, Tesla, yeah, sorry, yeah. So this is really looking at sort of providing a service to the people, not just a vehicle to get you from A to B. So they have sort of advanced diagnosis systems and monitoring systems as well. Another example is smartphone. These days, this is coming out of the New Zealand web page. You can buy a smartphone for $0, so you don't pay anything for the actual physical product. And you pay for the plan, of course. You pay for whatever plan that you want to buy it with. One extreme, okay, so the actual physical components is zero, worth nothing. And you have to buy the service. And they come together, so that means you can't have one without the other. I mean, you might say, look, I just want the phone to use as a camera. I don't want to use it as a phone. Well, that's fine, but that's probably not what the customer initially designed for. Well, so that's service aspect of this manufacturing. And then how do we define cloud manufacturing in this context? Well, this is my definition. It's published in this paper in 2012. I mean, we're really looking at sort of utilizing cloud computing sort of concept. It's basically looking at a network access to a pool of manufacturing resources. Now, we're actually generalizing manufacturing resources in a broader way. Things like software can be part of the service, and equipment, capabilities, and anything else that you can treat, you can actually sort of offer to other people. These services can be rapidly provisioned and released with minimum management efforts. So it's looking at capturing different manufacturing services and offer that to the customer. So that's the concept. Just a couple of examples there. Manufacturing involves design, so design is often considered as key components of manufacturing business. But design software has been sort of making the headway there, offering as a service. This is what I call low-hanging fruits for cloud technology. Well, there's different CAD systems out there. Autodesk is one of the early ones, still around. They are the first people offering software as a service. This is a design platform as a service, PaaS. So what they've done is you can actually purchase their service online without having to buy annual license, whatever. So the different fleet of their products is product lifecycle management, simulation package, and fusion for 3D direct modeling, and computer-aided manufacturing as well. So it's a pay-as-you-go model that software companies are offering. There's a lot of benefits of doing that. You don't have to invest good computers in your company. You don't have to manage your licenses. You don't pay annual license. once you have updates, you don't need to sort of go and physically update yourself, and because the server will update for you. So there's a lot of benefits there, and they offer different different type of services there. And if you look at the cost benefit here, you pay just under $7,000 for 120 jobs. And if you pay annual license, traditionally that's how much you pay for 1 year plus the maintenance fee there. So it works out. If you only do once or twice, you use once or twice a week, their systems, you're much better off to use that pay-as-you-go model. Unless you say you probably use twice or three times a day and 365 days in a year, and then probably you pay that annual license, that will probably come out on top in terms of saving software cost. So it depends, still depends, but I think attractions are here. In our university situation, we use different packages for our courses, and we only run our courses in 1 or 2 semesters, and even in 1 semester we only use perhaps a particular software for 3 weeks, for example. We don't need an annual license. We only need to pay for 3 weeks of use. So this is actually quite useful for us as well. For normal businesses, maybe it's not the case, but it must be. There will be benefit if it's not heavily used, of course. Well, that's on the software side. This is more sort of on the industrial system side. This is the project that we've been working with a research institute from Stuttgart in Germany. So we're looking at the industrial systems. In this case, these are machine tools. How we can utilize these resources in the cloud to support multiple systems in the factory. So things you might want to do, such as PLC control, robot control, motion control, and collision detections, and CNC, of course, as well. Now, the way it may work is like this. We're looking at a cloud-based control as a service. So what we have at the moment is, if you're controlling an industrial system, you have fairly sort of complicated computational parts plus the process parts sort of combined together in the local resources. Maybe it's packaged in a controller on your machine tool, for example. And very often this computational part has got IP there, has got an intellectual property embedded in there, which probably has more value than just the process part, which is basically a very low level data to communicate with hardware to realize whatever you have calculated and processed. So what we're looking at is can we actually move this out of this local resources to have it in a cloud? Then this can serve other systems, and of course you have to have some way of communicating with other systems. In this case, you want to communicate with multiple machine tools, for example. So and once you can do that, then you can offer your service in a cloud to different systems. Now, there are still technical issues that we're working on, of course, and how do you make this happen? Of course, you can't have real-time control through the internet at the moment. And so really the scenario is to have some sort of platform here as a flexible control platform. Then you have plugins for factory functionalities, whatever you want to do. You want to simulations, HMI, and manufacturing execution systems, and ERPs, and others. So the idea is offering a cloud-based platform that house different services, and then you can plug in and coordinate different services. So it's a platform as a service, the way I see that. Now, we've been working on this for some time, but really, what is the catch for industry? And when you go out and talk to people from industry, what do you talk to them? Well, there are two different groups. I think there'll be one group that actually asking for services, and the cloud-based technology will serve well for these people, because you don't have to invest yourself if you can use other people's service. So shifting the capital expenses to operational expenses, and business become more agile as well, and you can have access to innovation in a quick way. For businesses that has got unique services that they can offer, or spare services, capabilities that they can offer, there's also a lot of benefits. They can have access to a large pool of customers if they have it in the clouds. It can improve productivity. This is better utilization of the resources if you define productivity in that sense. And business is more agile as well. Well, there are actually quite a few things that industry has to look at before they embark on this type of system. First of all, the data has to be sourceable from different places, and so this is from hardware. So it has to be cloud ready, because these days businesses have their legacy systems which doesn't communicate well with other outside worlds. So how do you make sure that the legacy systems can actually give you the data that you need? So this is a lot of work going on at the moment. So we were in Germany and visiting technical university cabinets, and they actually looking at retrofitting a machine tool which is 30, 40 years old, and how do you actually put in some simple sensors and get some data out so you can do some communication. So that's important. The first thing you have to do, of course, and then of course the connectivity as well. So it's not just enough just getting data from a system, but also you want to have systems communicating with each other and talk to each other. And I talk about data. You have just too much data, and how do you actually process it and make sure that you have useful information from that. A business may have different resources, and they may need resources from other people, but they also may offer resources to others, and they may want to have, may want to decide what services they want to keep in-house and what other services they can offer to other users. So that's actually a fairly sort of business strategic decision that company has to make. Then resources can be offered in a very tight sort of private cloud environments. It can be offered in a community clouds and or public clouds. So there's different options there as well. So business need to think about it. I think we're coming to the end now. Now again, we're looking at very similar structure as the service-oriented architecture there. Here is the here is the user of the services. This is service providers. So we're looking at developing some sort of cloud management system which can actually register the services, and the user will request services from the clouds. You may ask, what do you mean by manufacturing services? What are the resources that you can actually capitalize? You can actually capture and offer as a service. Well, in real sense, anything that happens in the factory can be a service. Can be real resources related things like soft resources and software knowledge, hard resources as well. This is manufacturing resources or whatever, and capabilities. This is sort of at a higher level in terms of what company can offer. And of course, these are all interconnected. And I think what's more important here is these capabilities, when these are captured as a service, which has more meaningful sort of appeal to the customers, rather than just offering a machine tool. Here you go, you can use the machine tools, but what's important is actually package them, offering as a service. I think we're running out of time here. I just want to give you one example here. This is a European Union project funded by a European Commission. This finished in 2013. So it's perhaps the first project that European Commission funded. So this is looking at manufacturing as a service. So it's developed this manual cloud which interact with the manufacturers, getting the services organized here, and the user will interact with the manual clouds, not interacting with the factories directly. So I just sort of quickly show this. I think I just finish off with a few concluding remarks, and I can take on some questions. Well, cloud computing changes the way the manufacturing enterprises do business. I think that's what I want to say. While this cloud computing or cloud technology, I think should also include cyber-physical system concept. It's important really address issues from the industry perspective, and so we need to address the real needs of industry rather than talking about something that sounds good. But business have no interest. They don't want to want to have a bar of it. Well, a few things that's key for cloud manufacturing, or if you like, Industry 4.0. Data connectivity, and I'll talk about that, repeated a few times. And data process analytics and synthesis as well. And cyber-physical system, of course, and Industry 4.0. And smart factories. Well, the cloud concept for manufacturing, I think, is quite sort of unique in a way for countries with many small, medium-sized enterprises, SMEs. This is only true for New Zealand, because the government is looking at sort of setting up a New Zealand incorporated model, meaning we are a big manufacturing company in New Zealand. Let's come together and how we utilize the expertise the different businesses have, so that we can compete. So it's really sort of coordinating resources in a way. So the resource providers and the resource users, win-win situation there as well. And if you can coordinate these different resources together, you can form some sort of virtual enterprise. So you have more capabilities to compete with other people. You have ability to take on bigger projects as well, rather than individual small businesses going out and trying to talk to the big players. So I think that's me. Thank you for your attention. I'll be happy to take questions. Thank you. Yep.
First question. Thank you. Very interesting presentation. But now, as you are foreseeing that this kind of cloud manufacturing is coming and changing how things are manufactured, we know that the current manufacturing hub of the world is China, and most of the things are done there. Where will be the new hub for manufacturing in this cloud manufacturing phase? Will it move from China to Google or Amazon or other cloud service provider, or will it be everywhere? What is the role of additive manufacturing? Will everybody have the 3D printers and so?
Very good question. Thank you. In China, I think China is one of the countries started cloud manufacturing research ahead of many other countries. I think they started in 2009, 2010. China is very sort of has a very unique sort of environment in terms of manufacturing capabilities. It has got a lot of state-owned big enterprises, manufacturers, big players. Then it has a lot of small, medium-sized manufacturers. These are the companies from the south of China. So the first project that they've done in China is actually set up a cloud manufacturing platform for those companies in the south, in Guangdong province and that area, to coordinate the resources from individual manufacturers. So that is, as we talk, and still that is going on now. I don't know where this is going in 5, 10, or 20 years' time, whether the manufacturing center will be shifted to India, to, I don't know, going back to the US or back to Europe as well. I guess one thing I'm sure will happen is the boundary will be open. So if there is a functioning manufacturing cloud in China, I'm pretty sure what will happen next is it will branch out, it will reach out and get connected to other overseas businesses. So I think it's perhaps things become more globalized rather than regionalized, like what we're seeing here now, China as the world manufacturing center. I think that is going to go away when we have more interactions between businesses. And your comments on additive manufacturing is quite appropriate, because a lot of researchers, they're doing research in this area, actually use additive manufacturing as an example to test their research outcome. Because it's easier, and we already have some systems online, like Shapeway and other systems, because additive manufacturing is all about you do a design, and this is the data, you send it to somebody and to the 3D printer and print it out. So there's less sort of resources involved, if you like. So it's much easier to showcase concept. Well, that's actually worked already, and well, I don't think that's well, people probably shouldn't think this as a real example of cloud manufacturing, because additive manufacturing, after all, is much a sort of simpler scenario compared to complex manufacturing scenarios for car manufacturers. Yeah.
Yeah, I love the idea of flexibility, efficient use of factory resources and so on. And I'm buying manufacturing nowadays, and it would solve some problems, like flexibility, or where can I get this quickly, or so on. But there's one thing that is even more important, and that's quality. And how can you solve the quality issue on this when at least currently the thing is that you stick in one factory, you specialize in one manufacturing line, you travel there yourself, you fail with a couple of first production runs. After a couple of weeks of production, you start to get the quality in place, and then the network shifts the manufacturing to another country. As a buyer of manufacturing, I would be very concerned and hesitant.
A very good question there. I get the two aspects there. One you actually haven't quite touched upon. The first thing is, how do you make sure that the service that you purchased actually give you the right service? Quality is one thing there, of course. Cost is the other thing. Well, I didn't talk about the details of how this thing may work, the mechanism of how cloud manufacturing system can work. There's one key thing in that is the service level agreements, SLA. Well, it has to be captured all in that documents, because quality, it has to be captured in there, cost and everything, and has to be agreed upon by the two parties there. And if, say, look, you didn't actually, in the end, you didn't give me the product, you actually, component you gave it to me is actually not to the right specification, then there's a liability there, and you know, I won't be paid for that. Well, once this sort of culture is there, and the service providers will be aware of the responsibilities, and they will make sure that they do provide the right service. And of course, then the service users will have more confidence about, oh yes, I think they understand the service level agreements and they've done this in the past. So there has to be some sort of, how do you say, you need to have a time to sort of make sure that the whole documents, the policies, agreements actually are in the right place and people have a good understanding.
Kind of solution, but then the price is very high if I'm ordering small lots, so this would then only work for something that I really like mass producing, and this whole concept wouldn't then apply to like ordering small quantities, or because then the price would be but just so prohibitively high.
Well, I think that's interesting.
For guaranteeing quality.
Yeah, that's probably a different dimension that we're talking about, mass-produced and more sort of customized, one-off system you're making.
If I know as a buyer, and if the factory knows as a seller that it takes a couple of weeks to ramp up the quality, then it will be in the price.
Yeah. Well, it's all about how you build that into the whole service you're offering. If you think, look, if I have to make this for you, I look at my resources, I probably have to buy a few new piece of equipment, so I build that in. And if you like it, you take it. If you don't, if you think it's too expensive, I won't. I think that you actually touched upon about the consumer confidence about the products that's made by multiple service providers, whatever, rather than traditional big factory. Things like Nike, and they used to sort of produce things in their own factory, but now you can buy Nike product made from Vietnam, from China. Mercedes-Benz cars, of course, and you can buy cars in China, made in China. It's not made in Germany. Cars made by Japan is not made in Japan either. Well, how do consumers now have confidence? They still think they're driving the right car. Well, that's all because they've gone through those different stages and making sure that everything actually works out and actually has got the right quality in different stages. I think that's what we're seeing. So we still remember when I was a little kid, and we get a lot of product from Japan, and we actually worship things coming from Japan. We like to have things made only for Japanese people, but then somehow comes out of Japan and to China, and that must be very good because it's made locally for their own population. Well, it was true at that time, but now not anymore. I mean, the cars made in different parts of the world, as long as they have the same brands, and probably will have the same functionalities.
Continuing a bit this idea of China being the manufacturing hub and probably remaining that in the future, can you elaborate a bit how you feel that where the value is moving from the hard manufacturing to the soft side to the service side? So can you indicate trends, or how do you see?
I think this is in the leadership's mind in China as well. They long time ago they realized this. Yes, China make a lot of things, but also they have pollution problems, because if you make too many things in the country, you're big polluters in the world as well. And so I think they're looking at sort of that soft part of contribution to the final product. I think they're looking into that at the moment. And if you look at other big businesses around the world, and they also realize that sometimes they do things in-house. R&D work, some of them they're still doing in-house. But if you look at Daimler situation, we were there last week. They actually set up a IT development center in India to develop some of the codes for their car. Well, because they realize the people in India, they're very good in IT, they're good at programming. Google, for example, as well. So I think it's perhaps not a country trying to do everything together. It's basically a few countries having their...
But the value of the soft side probably is increasing relative to the hardware side.
I think that's the trend we're seeing here. I think that's the trend we're seeing. Well, it's probably, I mean, it's hard to say, look, hardware only worth $5, software worth $500. I mean, probably it doesn't work like that. Hardware maybe still costs a lot to make. Yeah. But I think the service that the people, the perception that people have over a product will be more on services provided rather than the actual thing they're having.
Yes, let's take last question because we're running late. So,
yeah,
and we will then close.
My question is about this globalization. That in the past, 10 years ago, it was a great fashion that in order to maximize the quarterly wins, you outsourced everything to the lowest bidder, every manufacturing part, and it worked for few quarters, and then it didn't work any longer. And now the trend is back to have the manufacturing within your reach, within your own cluster, and somehow getting the early seeds of ideas and possibilities what can be manufactured as your like a competitive advantage in your services. So is this trend of having manufacturing back in your soil and nearby in your innovation cluster, is that strengthening, or do you see that everything will be fully global and the lowest bidder in India will get always the deals?
I don't think there's a clear cut there. It's a sort of more gray situation rather than black and white, which way we're going. I remember when I was in the US, this is 3 years ago, and Obama was saying, look, manufacturing is coming back to America. We're starting Apple iPod manufacturers in somewhere in the US, I don't know. You know, we're not outsourcing anymore. Well, I think only to some extent. The key thing here is what is driving your products, I think. Is the physical part of the products, or is actually the soft part of products? I think that one has to really understand well. I can't give you a clear answer where we're going. I'll probably say that for innovation to take place, to have a good ecosystem for innovations, we probably need to have some manufacturing capabilities or prototyping capabilities, together with R&D capabilities. You know, I don't think you can say, look, we actually investing a lot of money in developing these ideas into products, but I'm actually using somebody else thousands of miles away to actually produce the thing for me. I think because the design, concept, and manufacturing, they sort of couple together really so closely, ever so closely these days. You really want to have a quick feedback. But what is a good ecosystem for innovation? I don't know. Maybe you have have a good answer to that. But I don't think it will work if I only do thinking here, and I have people sort of in another city doing design work, and then somebody else in a different country doing manufacturing work. I don't think that's a good ecosystem.
Okay, I think we are. I'm ready to stop sort of the official part of the presentation, and then if you have individual questions, I'm sure Professor Xun Xu is willing to answer them. But thank you for your presentation.
You're welcome.
Let's give a warm hand. And I believe this was the last lunch talk of the summer, and then we will continue in August. So thank you for everyone.
Can you tell what kind of collaboration there exists between Finland and